This is the solution video for section 6.2, problem number 26. All right, so I have f double prime of x equals 16 times cosine of 2x minus 3 sine x. And I'm told that f of 0 equals negative 2 and f prime of 0 equals 4. So the directions here just say solve the differential equation subject to the given conditions. All right, so remember, if I have f double prime, I'm trying to ultimately find f of x, right? So this is a double differential equation. So first of all, I need to recognize that f double prime of x is really just the derivative of f prime of x with respect to x. So that means that the derivative of f prime of x is 16 times the cosine of 2x minus 3 sine x. All right, and so I'm going to multiply by dx, and so I have df prime of x equals the 16 cosine of 2x minus 3 sine of x dx. All right, so now I want to integrate both sides. All right, so on the left side, the integral of the derivative of f prime is f prime of x equals. Now remember, it would be a plus c, but I'm going to put that plus c on the other side. All right, so now I have 16 times the integral of the cosine of 2x. Now, it's important to remember that I'm going to need essentially two separate integrals. So I'm going to need the integral, 16 times the integral of the cosine of 2x dx minus 3 times the integral of the sine of x dx. Now, I really need to consider it two separate integrals because I have the cosine of 2x, and so I'm going to need a u substitution. All right, and so I get, I'm just going to go on the side here, u equals 2x. Now, I'm only using u in this first integral. I'm not using u in the second integral. So du is 2 dx. So that means I have the integral of cosine of u, and then I have the dx. So I need a 2 with the dx. And I had the 16, right? And so then I'm going to need to divide by 2 on the outside. Now, remember, I'm not using the u here. So this just remains as minus 3 times the sine of x dx. All right, so now remember the 2 dx right here is du. So I have 8 integral of cosine of u du minus 3 integral of the sine of x dx. Don't get mixed up here. We're using a u in the first integral and not the second. All right, so now I have 8. All right, integral of cosine is sine of u minus 3 times the integral of sine, which is negative cosine of x, and then of course the plus c. So I have f prime of x equals 8 sine of u, but remember, we want to replace the u. So 8 sine of 2x plus 3 cosine of x plus c. All right, so now I have f prime, but remember, I need to find f of x. All right, but before we do that, we need to find the value of c. Now remember, I'm going to end up integrating twice. So this is going to be c sub 1, and then later we'll call the other one c sub 2. So I know that f prime of 0 is 4, so I'm going to write that 4 is equal to 8 times the sine of 2 times 0 plus 3 times the cosine of 0 and then plus the c sub 1. All right, so plus c sub 1. All right, so 4 equals, all right, 8 times the sine of 2 times 0. Sine of 0 is 0, so I have 8 times 0 plus 3 times the cosine of 0. Cosine of 0 is 1 plus c sub 1. So I really have 4 equals 3 plus c sub 1. So subtract 3, so c sub 1 equals 1. All right. So now, okay, I have my f of x, or sorry, my f prime of x, which is 8 times the sine of 2x plus 3 times the cosine of x plus 1. All right, so now we want to recognize, I'm going to go up this way. We want to recognize that f prime is actually just the derivative of f of x dx. And so that means the derivative of f of x is whatever we just got there, right? So that means df of x dx is 8 sine of 2x plus 3 cosine of x plus 1. All right, so now I'm going to multiply by dx. So I get that df of x equals the quantity 8 times the sine of 2x plus 3 times the cosine of x plus 1 all times dx. So now once I separate the differentials, I can integrate. All right, so on the left side, the integral of the derivative of f of x is f of x, of course, and then plus c, but remember that plus c is going to end up just on the other side. So f of x equals. All right, so now, once again, just like I did earlier, I need to do a u substitution. So I'm going to do a u substitution, but only on the sine of 2x, right? So it's going to be the same u substitution. So u equals 2x. So I have 8 times the integral of the sine of u dx. And then I have the plus the integral of 3 cosine x plus 1, right? Now, I'm going to leave that as a single integral, right? Because we're not using u substitution there, right? So just like earlier, I'm going to put a 2 with the dx and a divided by 2 on the outside of only that integral. And so now I have f of x equals 4 times the integral of the sine of u du plus the integral of 3 cosine x plus 1. And remember, this is still with respect to x. All right, so now I have f of x equals. All right, so I'm going to integrate. 4, integral of sine is negative cosine. So negative cosine of u, but remember u is 2x, plus integral of 3 cosine. So 3 times the integral of cosine, which is sine x, plus the integral of 1, which is x, and then plus the c, we'll call that c sub 2. All right, so now I want to solve for c sub 2, and so I need to use what we were given, that f of 0 is negative 2. And so I'm going to plug negative 2 in here, and I have negative 4 cosine of 2 times 0 plus 3 times the sine of 0 plus 0 plus c sub 2. All right, so negative 2 equals negative 4 times the cosine of 0. Cosine of 0 is 1, plus 3 times the sine of 0. Sine of 0 is 0 plus c sub 2. So I get that negative 2 equals negative 4 plus c sub 2. So now I'm going to add 2, and I get that c sub 2 is equal to positive 2. So that means that my f of x function is f of x equals negative 4 cosine of 2x plus 3 sine of x plus x plus, and then the value of c sub 2 is 2. So this is my final answer for f of x.